Hey everyone and welcome. Today we're going to dive into a really core part of how your computer works, its memory. More specifically, we're going to demystify this thing called secondary storage, which is basically the place where all your digital stuff, from your operating system to your photos, actually lives.
It seems like such a simple question, right? But it really gets to the heart of how computers work. You save a document, you shut down your machine for the night, and when you turn it back on, it's still there. So how does that happen? Well, it's not magic, it's memory. But probably not the kind of memory you're thinking of.
You see, a computer's main memory, what we call RAM, is incredibly fast. It's like the computer's active workspace where it does all its thinking. But, and this is a big but, it has one huge flaw. It's volatile. And that means the second you cut the power, poof, everything it was holding is just gone. So yeah, it's brilliant, but it has absolutely zero long-term recall.
So, to solve this pretty major problem, computers basically use a two-part system. You've got that super fast temporary primary memory, that's the workspace. And then you have its essential partner, secondary storage. Now, it might be a bit slower, but it's non-volatile, which is the key. It holds onto your data even when the power is off. Plus, it comes in way larger sizes. This is the digital treasure chest where all your files are kept safe.
Okay, so this is what we're really diving into today. The computer's long-term memory. It's the unsung hero that makes sure all your important stuff doesn't just vanish into thin air. We're talking about secondary storage.
So what is it exactly? Well, putting it simply, secondary storage is any non-volatile device that's built for permanence. The whole point is that it holds onto data for as long as required. And that means you, not the power cord, are in control. And what's it actually storing? Well, pretty much everything that makes your computer your computer. The operating system that boots up, all the apps you use every day, the drivers that make your hardware work, and of course, all your personal stuff, your documents, photos, and music. Seriously, without secondary storage, a computer is just an empty box.
All right, so before we jump into all the cool types of storage out there, there's something we've got to clear up. It's a really common point of confusion, the difference between media and device. And trust me, getting this distinction right is absolutely crucial to understanding how this all works. So let's break it down.
First up, storage media. This is the actual physical thing that holds the ones and zeros. The best way to think about it is like the paper in a book. It's literally the material that the information is recorded on.
And then you've got the storage device. This is the piece of hardware that actually does the work. It reads the data from the media and writes new data to it. So if the media is the book, the storage device is you, the reader, or the printing press that made it in the first place.
Okay, let's make this super clear with a perfect example. You take a Blu-ray disc, right? That shiny disc itself, that's the media. It's the physical object holding the movie. And the player you pop it into? That's the device. It's the machine that spins the disc and uses a laser to turn all that data into the movie you're watching. See? One holds the data, the other reads it. Media and device. Simple as that.
All right, now that we've got that straight, let's start exploring the three major categories of storage. And we're going to begin with a real classic, the workhorse that's been the backbone of computing for decades, magnetic storage.
And this right here is the classic hard disk drive, or HDD. What you're looking at are these shiny metallic platters that spin unbelievably fast. We're talking thousands of times every single minute. That little arm you see hovers just fractions of a millimeter above the surface, using magnetism to write and retrieve your data. It is honestly an incredible piece of mechanical engineering.
So the most common example, of course, is the good old HDD you'll find in a lot of desktops and older laptops. But it's not just that. This category also covers things like portable hard drives, and you might not see these much anymore, but they're still vital magnetic tape drives, which are super important for huge-scale backups.
Next up, let's move on to a technology that pretty much defined an entire era of music, movies, and software: optical storage. And yeah, just like the name suggests, this one is all about using light. So here's how it works. A superfocus laser actually burns these teeny tiny microscopic pits onto the surface of a disk to represent data. And then, to read that data back, the laser just scans that same surface. A sensor picks up how the light reflects differently off those pits versus the flat spots, and that's how it reads the ones and zeros.
Oh yeah, and you definitely know these examples. It all kicked off with the compact disc for our music, then it evolved into the DVD for our movies, and finally we got the Blu-ray disc for glorious high definition. And the crazy thing is, each step of the way, they were just cramming more and more data onto a disc that was the exact same size.
All right, and that brings us to our third and final category, which is pretty much the modern standard for speed and toughness, solid-state storage. And the name really says it all. There are literally 0 moving parts inside.
I mean, the most familiar example for pretty much everyone has to be the good old USB flash drive, right? Inside this tiny little thing, there are no spinning disks, no lasers, nothing like that. Instead, all your data is stored electronically on these things called flash memory chips. And that's why it's totally silent, way more durable, and just ridiculously fast.
And this tech is, well, it's everywhere now. We've got solid-state drives, or SSDs, that are replacing those old mechanical hard drives and making our computers boot up in like seconds. We use them in USB drives, and of course, in all the memory cards for our cameras and our phones. Honestly, their speed and just how reliable they are has made them the new gold standard.
So there you have it, folks. The 3 pillars of storage that allow us to save our entire digital lives. The mechanical wonder of magnetic, the light-powered precision of optical, and the silent, blazing speed of solid state.
And at the end of the day, it doesn't really matter which technology we're talking about, whether it's magnetic, optical, or solid state. The fundamental goal is always the exact same, to give us a permanent place to keep our data safe and sound for as long as we need it. It is, no exaggeration, the very foundation of our digital world.
And that kind of leaves us with one last big thought. Think about it. We are creating an absolutely staggering amount of data every single day, more than at any other point in human history. These 3 technologies have gotten us this far. But as our digital universe just keeps expanding at this exponential rate, what's next? What's the future of storage going to look like? That, my friends, is a question for another day. Thanks so much for tuning in.